Yes, we're live. Maybe I will share my. I don't remember. Okay, it there. I will share everything. So, entire screen. Okay, so we're going to wait a little bit to see if we're going to be only you and me, or if other people comes.
Sounds good.
Yeah. Yes, we can check. You see my terminal?
Yes, sir.
Okay, perfect. So we are good. And this is almost the last one. There is that one on bolt on the bolt 11, and then the next one will be the last. And I will try to do something really cool, where we put all that we did in the first session in one. And if we can, we're going to implement a command invoice that generates an invoice entirely using Core Lightning, but in one shot.
Very cool. What's do you know the status of Bolt 12?
I just seen that Eclair released V010, I think. I'm not sure, but today, and they have Bolt 12, or they make it better. So maybe soon it will be in the spec.
Cool.
Okay. Maybe I will go on Twitter. Just say that we are live and we go. Okay, and now I will retweet this one. No, what? Okay. Yes, let's go. We are in some live 23, but this is about 7. Okay, so let's go for that live. And so far in the 6 first episode about Bolt 11 invoices, we talk about many aspects of the implementation in Core Lightning. Also, some part of the protocol, how it was implemented, how do we get the data, how do we transform it into beg32. Last time we've seen how to sign not the entire invoice, but most of the data in the invoice. And today it's not totally related with Bolt 11, with the protocol, but just one aspect of Core Lightning is that when we generate an invoice with the command invoice, at some point we want to store it in the database. So we are looking to this today. So how it is stored, at which point in the code this happened, and what I would like to do. I found that example just this morning, so we are going to try to implement it right now, which is we are going to write a command. We're going to play with the database. Okay, so to play with the database of not the bookkeeper database, but the main database of Core Lightning. We're going to see how to modify it, so to add one table that we're going to call foo with one colon bar, and we also are going to add a command that we call foo, and that command just if we make it, we pass it one integer, and we add that integer to the database. So I hope we will find the way to make it. It worked this morning, but maybe I don't remember all the part and everything fall apart. But let's try to do that and to play with the database. So maybe the first thing that we can do is we are going in repo Lightning. So I have the Lightning repository in that place on my computer. We open a terminal. Let's maybe make clean to clean what was before. Configure. So we configure with Disable Rust because we don't use the Rust plugin. And maybe we can just compile it once, and then we're going to start as we do with the script in the contrib repository, some nodes running on reg test, and we are going to look at the database. Just we take a look. Maybe we generate an invoice, and we see that that invoice is added to the database. Then we look at the specific place where it is done in the code. Maybe we are going to go to browse in the code and see what's happening. So doing this source contrib startup request, we can see that we are taking the binary Lightning B and Lightning CLI, which are in that repository that we just compiled. So each time we recompile, we are going to use those one. Start ln, so we start two nodes. And we can see, so as always, we look at this alias, this one, and we see that we are in the Lightning beer, which is temporary L1 reg test. And now we have a database there, but we are going to maybe L1 CLI get info to see that we have something running. So maybe just the node ID. So we have something running with the node publicly of the node, which is this one, the node ID. And I will open another terminal here because repo Lightning, we go there because this terminal is running inside my editor and it's not that good. And when we there are some blob in the database that will kill my my other terminal. So we do it this here, and now SQLite 3, temporary L1, and here we're running on reg test. So this is that subdirectory. We can press tab twice, and we see that what we have so far, and we want that one. Okay, so let's go here, and we maybe, so if I remember correctly, so this is all the tables that we have in that things. One thing, we have the version. So version is important. It keep the version of the database, and this is used when there is a migration. So the version only can increment from one or doesn't increment, but if it increments, this way we can, there is a check when we start the node that say, do you have a database? If it's not, we create everything. And if we have an old version, we are just going to do the migration between that new version to the next one. So maybe we can do something like that. So select everything from the database version, and we see we are at the version 249 for the database. And if we look at the invoices database table, we see we have nothing, because we still didn't generate any invoice. So now let's just create an invoice. CLI invoice 10,000 millisat, unique label, let's call it label 0, and description. So we've generated something, and now if we go in that terminal and we select the invoices, we see that we have a row for that invoice, and here LNBC RTC, this field is the how to say that, is the lightning invoice. We have the label there, and here we have at the right we have the description. Okay, so when we generate with the command invoice, we also store something there. So please, so Drew, if you have any question, you can cut me at any moment, and I will explain if I can. So we have that. So now we've seen in the previous episodes that when we do a L1 CLI invoice, that we call the command invoice at some point in the so we go there in the Lightning repository, specifically in lightning invoice.c file. So you can see in the bottom, in the green line, the file name. So we go into that file, so lightning invoice C, and we look for JSON invoice. So what's cool, I think, with doing several parts in the right order, so we can refer to the previous one. So this is where we define the invoice. So let's go back to the terminal. When we call that command, lightning invoice, the code that is executed is that one in that function. And we see here we get the parameter, and we see that we have the amount, we have the label, we have the description, and this is what we've passed, and those one are required. Okay, so this is the one that we passed, and after we do some stuff. Okay, so because we want to produce the data, we specifically here we create some a structure, a struct B11, so we can look at that struct. So this struct bolt 11 with all the information that we want: the payment hash, the receiver ID, the description. So we go back to that function. So we fill all those information stored in the field B11 of the info struct. We continue, we do some stuff. So this is some stuff. Some of them we've seen that before. Some of them you can look at them after. Something that can be done, and it is done in a core Lightning by default, is if we can add root int in the invoice. So meaning that we help the payer, giving it some nodes to pass through to pay us. So to do that, this is done. This is we need to have some list of the node incoming, so list incoming, and we check this is done by a plugin. So do we find a plugin with the command list incoming? Yes, we find it. This is here, and after we go into the invoice complete. And we look at that because, so let's jump into the invoice complete function. And this is where several things happen. So one of them is the encoding that we've seen last time. With the signing function, HSM sign B11. So I try to go. I don't know if it's fast, but it's just that because I want to look at the database and I want to write some code to. So because I feel that I will make some mistakes. So we are there, and we use that function bolt 11 encode. We pass it that information about the data that we want in the invoice, and B11 enc. This one is the so if I'm not yes I'm right. This is the bake32 string. So exactly what we see. No, not. I want to go to the terminal, and this is that one. So at that point, let's go back here. We've calculated the invoice, but now we want to add it to the database. Here, we just make a check that don't allow to have the same preimage. So when we send when we generate an invoice, there is a hash that come with a preimage, and when we get paid, we give back that preimage so that the payer can check that he paid us. So we don't want to have several invoices with the same preimage. So here we do a check, and then at that point, this is that call, if it works, that put all the information in the database. So we are going to look a little bit at that, and anyway, we are going to copy some parts of the invoice create to see how it is done. We pass it the wallet invoices, and in the wallet invoices we have the DB. So one thing in core Lightning is that when we start Lightning D, we have an object, a global object LD that contain all or some of the states. I think that all the states of the Lightning D, and one of the field is the wallet, and in the wallet we have also the database. So maybe we can look at the wallet. So we get it that wallet from the info that is passed as argument. So we are still in the same function. Huh? And if we look at the wallet, the structure of the wallet, this is that one. It's up. What did I do? Okay, this is this one. And we see that we have a DB, the database, and in the database we have the connection, and with that connection we can do some stuff. Okay, so that one is really to pass in invoices is also, sorry, I should mention invoices. We have it here, and invoices. Yep. So if we have the invoices, we have a field in invoices that also have the wallet, and the wallet has a field which add the connection. So if it's not clear, it will be clearer in the last part of that live. And then here we pass it the information that we want to store in the database. Okay, and this is invoice create. So we jump to invoice create, which is in the code of the module wallet. We can see so wallet underscore invoices.c, And in that code, we do what should be done, and we see here we save to the database. We look, we see that we have some an instruction insert into the database invoices, and we see what we insert. We do that with db prepare v2 is a wrapper because so Lightning D can use SQLite 3 or Postgre. I think it is the other. And so there's two code, maybe we can see that. Yes, it's Postgre. So there are two, this wrap and decide which one of the two database we use. But anyway, we see here, we have the DB, we have the database which has the connection. We pass it that things which is stored in a statement. Okay, and in that statement, we see that we have some parameter that are only equal sign. So those equal sign will be bind by those functions db bind u64 db bind foo. So at the end, we transform that statement struct that will be used. We are using SQLite 3. So let's just talk about this one. So this statement, one of the field, what we are doing there when we prepare is that we compiled into it's not into bytecode that then is evaluated with here db exec prepared v2. And do we see something else? I wanted to say something here. Maybe it's not there. Let me see something. So, stmt. Because this is passed. Okay, anyway, the thing that is done, so we can see the things that that's done is that we pass it an SQL request here with some parameter integration that we bind after, and when we execute that statement, we write on the database or we read in the database. So with that said, let's go back in our function invoice complete. So we call, if we go to the terminal, we call the command invoice. Then we go here. So invoice complete. Then what is executed is that code, the JSON invoice stuff, and we see that because this is declared with autodata. So this is the first episode that we did. We want the root because we want to add root int to the Baker32 invoice. So we call invoice complete, and in that invoice complete function, we terminate the encoding in Baker32. We check for an existing preimage in the database. If there is not, no problem, and we store that information in the source code, in the database, sorry. And if we can go till the end, and we see and that part where we are creating the JSON object that we return. So we can see that in the terminal, and in the terminal, Okay, so we can do a parallel. So we have the payment hatch in the top. We have expires at bolt 11, and this is exactly what we see in outputted in the terminal at the bottom. Okay, so with that said, with 30 minutes, can we create a new table, add a command, and insert something in that table? You ready? So I will drink a bit of water, and I go for the next part. And the next part is funny because it is the part where I can be wrong all the way till the end, or we can be lucky and do something that works. Let's see how it goes. Blah blah blah. Okay, first we are going to add a table. So we go in the file wallet, this one in the second line. So wallet /db.c, and that code is executed in when we start the daemon in Lightning D, but we are not going to lose. So we have that variable db migration, and these are all the statements that are executed at startup when we have no database. So they are all done. So we see this create table for the version. So we've seen that one. We can go to the invoice a little bit down. So there we have the invoice. So that we can see DB migration are executed. And if we are already at let's say the version 200 in that database, okay, and the DB migration contain more elements, the version will be DB migrations -1, and so we are going to evaluate only the statements that come after our version. And we can jump in the code and see DB migration where it is used. So in the function DB migrate. So DB migrate is called at the beginning when we start, and we can see, and let's look, okay, we can look at it. We get the DB version, and then array size of the DB migration -1, and we go further, and here we see that we prepare some statement, and we execute those statements, and we free those statements. So we go through each step in DB migration. So if we want to add something, we do that in the DB migration. And maybe let's and last thing to say here, in those specific struct, we have two parts. The first one, SQL, and the second one, which is null in that case, because this is the, how to say, it's just that when we migrate, or either we run that statement, the first SQL statement, or we apply the second function if provided. So let's look at this. We can see, for instance, migrate PR 2332 create channel. So if we have null as a first field, that function will be used to do the migration. Okay. So, perfect. So we go at the top, and we are going to copy that one. Please, what we are doing in that part, all we do is we do this in reg test. We are modifying the database. Don't do that in your node, please, in your main node, because you might lose your coin or corrupt your database, and your database is really important. So don't do that on your real node. We are running on reg test, and we are playing to understand a little bit the part of core lightning. Okay, so we take the first one, we go at the end, and we are going to add something else. So we the comma, create table, and we are going to call it foo. I always use foo bar bars to do the example, and normally this should work without any trouble. So let's compile. So this is, we can see here at the top, I'm running make-j12, and but we do this in the editor and not in the terminal. Okay, so we exit with success, as we can see. Compilation finished at the bottom. We see that, or the green in the green. Now we go in the terminal, and what we need to do is to stop the node and to also restart the node. So we could use stop totally, stop ln. I don't know if I did that, but anyway, I want to do just the node L1. So how can we do that? ph-x, I want the instance of lightning B for the node L1. So lightning B, and we have it at the top. Okay, so this is how it is started in the script. We can pass it. If we run that, we get an error, because this is lightning D is already running, but we can add at the beginning L1 CLI stop. We stop the node, and then if it's stopped correctly, we restart it. Up. Okay, one more thing. I need to add daemon at the end, because I want to use that terminal. Okay, so why can't we do that? Because maybe it's not running. Okay, so now it's we have it running, and we can check that L1 CLI JQ. We have the node running, and we jump into the other terminal, and what we would like to see if tables. Okay, and we see there we have the foo table. Okay, so we've added a table. Fine. So first thing first, we have that table, and we can do some select everything from foo. There is nothing, and now the work that we have to do now is to add a command and to see how we can add some integer into that that table. Still with me? Everything okay?
Rocking and rolling, yes, sir.
Okay, let's go. Let's continue. And now let's get a little bit fun. So let's go into this one. Let's go at the top. To go at the top. Okay, so this is the first part, the first episode that we did. And in the first episode of the Bolt 11 invoices, we see at the end we have the source code, and we've already seen how to add a command. So we are just going to copy one of them. The first one, so maybe we can use that one because we are going to. So the second one that takes arguments, and where are we going to add it? Just before invoice complete in Lightning D invoice.c. Okay, so this is what we need. So we are going to change some of the things. So instead of calling it JSON my invoice, we're going to call it JSON foo. This return in command results that we passed here. No, this is that function here in the JSON command that we need to call JSON foo. Let's say we call it dev. The name of the command is foo. Is it the name of the command? I think the first one, the JSON command, yes, the first one is the name, so we want to call it foo. And CLN live, this is 23, I think. So this is for the description. And last part, this is not my invoice command. See, yes, this is my invoice command, but we are going to change it for foo command, and we change that here. Foo command. Inside, we don't want all of those things, so we want something without any argument for the first one. So this is how we pass. We check if we have some parameter with the command, the buffer the param null. If it fails, we return fails. We start a JSON stream. So we must uncomment the JSON stream at the top. And we are not going to add JSON add amount, but JSON add U64, because this is what we are going to use. So JSON add U64 at the end, and maybe we can put added to database. So we it's not added yet, but we are going to add it after. And what can we pass? I think that maybe we can pass just one. Is it going to work? So let's say let's look if this works. So it seems to work. Terminal. Now we need to stop and restart. So we stop. We restart the node. And now we have a command called foo added to database, and we would like to add one to the database foo that add one column bar. So let's go back here. So this is, maybe I can make it a little bit like this. This is all we needed. So maybe let's remove that. Okay. So we are still in the part where we do the we define the command foo in Lightning D invoices. We called it, and we return one. It takes no parameter. So if we call it with a parameter, maybe 2, we see we have an error, too many parameters. Let's go back. No, this one. Now we are going to take a parameter. So take a parameter, required parameter. The name is bar, for the name of the column. Here, this is a function that we use, and we want param U64, and we have to pass that in a variable. So we define a variable here, U64, pointer to a bar. We pass a bar here. So normally this should work, and we would be able to pass an argument to that command at the command line. And here, we no longer want to the one, but we want the value of that we put in bar. Okay, this is done by that macro param, this one. So we compile, and we are going to see if there's some mistakes. We hope there is no mistakes. Let's restart the node. So we stop, we restart, and now if we pass 2, we see 2. If we pass maybe 3, we see that we 3. Okay, fine. So now we have a command. We can pass it an integer, specifically a U64, and now we need the important part of today, which is to add something to the database. So we are going to do it, and we want to add the integers that we pass to the command foo. So what we're doing, we're really copying what is done in the function invoice complete in some way. So what we want is to do something like that. We want to pass a database. So remember, the database is in one of the field of that argument of invoice create. So now we are going to create a function that we call invoices foo, and maybe let's just take that one, and we are going to call it here. We don't check for error. We're just let's say that everything works as we want. Command D is one of the arguments, and normally we have LD, which is the Lightning directory. In this one, we have the wallet, okay, and in the wallet we have a pointer to the DB. So we are going to pass it the DB, but we need to define that function, and we are going to define that function the same place at where invoice create is. We are in the file wallet / invoices, and now we are going to create that function. So bool, in fact, we don't care because we are not going to use that return value, but struct, and we want pointer to DB. I'm not wrong. Maybe we will need to, because do we have it? Yes, so we don't, no, this DB pointer, yes, it seems that we have it, and we need to give it a name, so DB. Okay, and here we return true. Okay, we pass it a DB, we return true. Maybe we can just compile that. No, so this won't work because we need to add the signature to invoice.hash, which is required in the Lightning D invoice.c that we are doing some stuff. Maybe we don't care. I think we can maybe put it here. So normally we should have some thing compiling or some errors. We'll see. But anyway, in that function, we just return true. So nothing is happening. So we see it's compiled, and let's run it to see. In fact, we don't need to run it because nothing is happening. But just in case, sometimes maybe it compiled, but we have an error at the runtime. So we just do that this way. Okay, so let's go back to our command foo, and we see where here we pass the DB to invoices.foo function each time we call foo. We would like to pass it also the argument, the bar argument, but we are going to do that after. First, we jump here and we are going to add some stuff to the database in a hard-coded way. So we need to prepare a statement, so to execute an SQL statement. So we are going to see here how it's done. So let's copy this one. Okay, and we see we save to the database, and we are going to modify it a little bit. So first we need to change this one, and the statement. This is a pointer to statement that we need to declare here, and we need to execute that statement at some point. Where it is, so when it's prepared, we execute, and we free that tal allocated not here but here. And now the DB that we pass, so the pointer to DB that we pass is a DB that we have add argument. So we can pass it directly like this. Maybe we put it there. Insert into foo in the bar element and the bar column, and the values that we want to pass, let's hard code that to 1. We end this, and we don't need this one. And after we are going, if we have some time, to see how to use the integration stuff. So normally, what we are doing now in the function invoice foo is we have a statement. We prepare the statement with that SQL statement, insert into foo in the column bar the value 1, and when it's prepared and there is no problem, we assume we are no problem there. We execute that SQL request in our database. And one thing that we have to mention now, let's go back into our command foo, is that I don't know exactly how it works, but this is something that is like this. Everything that happened in that command when it is called, the caller of that command, so the JSON RPC interface that manage that, open a transaction before running that part and close that transaction at the end. I tried to understand, but I didn't have enough time to figure that exactly when it's done. And why I've seen when it where it is done, but I don't know exactly how the JSON RPC exactly how it works. But when we do everything that we do here, we do that in a transaction. So this is why at that point we use this, we prepare and we execute. But okay, so let's continue. So let's compile, and I hope that we don't have too much errors, maybe none. Okay, so it seems to works not that bad. And now, first we go here, select. Let's go at the top. Select everything in foo. We have nothing, and I hope that you opt to. I know we don't care about the number because this is hard coded. We still use a 4. So no runtime problem. So maybe it did work, and yeah, cool. So we find a way to add a table named the foo in the database. We defined a command foo, then when we call it, we add the number 1 in the column bar in that new database. So let's do that again. We see that the number that we pass there doesn't matter much, but we see that we are adding something. So we have 8 minutes left, and maybe it will take 12 or 13, but I think that we can end with something cool. So bear with me. And now the last thing that we would like to do is that number here, the 6 that we pass, the argument of the command foo. We would like to pass it to let's go. Where do we go? We want to pass it to invoices foo that write in the database, and we want it to be written in the database. Okay, so first what we have to do is we want to pass the value of bar, so the U64. So we need to, we do that now. As we did that, we need to change invoice. So do we have invoice.hash? We need to change the signature. Okay, so let's change that signature, and we need now to change it also in invoice.c. We need to change the signature of invoices foo. Okay, so we change the signature. We are not using bar right now, but we are going to use it. The signature work. Now, we want to use that argument. How to do that? We want to be the value. So in that SQL statement, instead of hard-coding the value 1, we put the, I don't know how to call it, but the question mark there, and we are going to bind some value into that in the statement. So this is done by SQLite 3 in our case. So bind, and we bind U64. What do we bind? What? Don't remember. Yes, so we need the statement. Is it a statement? Yeah, this is a statement, and we want to pass it bar. And no, so sorry, I don't want to pass a pointer. We want to pass the number. So let's go back into invoice.h, and we change that for this. And we go back into lightning the invoices, and we see how do we pass it. Yes, because we pass the value and not the pointer to the value. Okay, so let's go back to invoices foo, and we see that placeholder, this integration will be bind to the value of bar that we pass to invoices underscore foo. Let's compile that and check if we have some errors or if it works just fine. Okay, so the compilation is okay, and now we restart. Let's we restart that, and we look at what we have. Okay, so we have the 2 that we did that were hard-coded before, and now let's put 2, no runtime error, and it has been added to the database. Let's do that with some other number, maybe 12. And we go back and we see that we have it in the database, the Lightning database. So Okay, it's everything that I have for you and for me today. Maybe we can go there, and the function that we have, maybe we can recapitulate. So in the file lightning_d/invoices.c, we defined a command called foo, and in that command foo takes one argument bar, which is a U64 number, and we call the function invoices_foo with the database as first argument, and the second argument is the value that we passed to the command, and we are going to write that argument in the database foo, in the column bar of the database foo, and that database we added. If we look in wallet DB, we see that the last line where we added that table foo in the DB migrations struct. So yeah, we are done.
Awesome. Thanks, Tony.
Thanks, Drew, and see you in 2 weeks.
Sounds like a plan. Talk to you later.
Bye.